All right, let's jump right in. Today, we're going to shrink our perspective way, way down. We're talking about a piece of technology that could completely change everything from medicine to space travel.
Okay, just think about this for a second. What if you had a power source so small it's practically invisible, but it's still powerful enough to run a tiny sensor for years? I know, it sounds like something straight out of science fiction, right? Well, this is the very real world of solid-state microbatteries.
For decades, we've had this dream of a truly connected world. We're talking about wild ideas like smart dust, or invisible sensors that could monitor our health from inside our bodies, or even check the safety of a bridge from deep within its concrete. But there's always been one giant hurdle: power. I mean, how do you power something that's microscopic?
Well, the answer isn't just making our current batteries smaller. The answer is a complete and total redesign of the battery itself. And that incredible breakthrough is the solid-state microbattery. This is not just a tiny version of what's in your phone, it's a fundamentally different and way better approach for technology on this tiny scale.
So here's the best way to think about it. A traditional battery is kind of like a cup of water. It has liquid inside that can spill, it can leak, and it's just messy. But a solid-state battery, that's like a block of ice. Every single one of its components is solid, which makes it incredibly stable, super safe, and absolutely perfect for shrinking down to an unbelievable size. So, by swapping out that liquid electrolyte with solid materials, we get a power source that's not only tiny, but also way more reliable and safe. And that stability? That's the real key here. That's what unlocks all of its incredible potential.
And oh man, the potential here is just staggering. This isn't some technical curiosity for a research lab. This is a technology that's ready to revolutionize entire industries. So let's talk about the real-world impact.
Think about this: a pacemaker or a glucose monitor powered by a battery that could literally outlive the patient. Because these microbatteries are so stable and last for so long, they could be implanted just once. That would eliminate the need for repeated, risky surgeries just to replace a battery. That's a huge deal.
Okay, now look at the world around you. With these little batteries, we could put a tiny, self-sufficient sensor on literally anything. A piece of clothing, a shipping package, a medicine bottle, and it could send out data for a whole decade without ever needing a charge. That right there is how we build a truly smart, connected planet.
And what about space? In space, every single gram matters. Solid-state microbatteries are a total game-changer for the aerospace industry. They let engineers build smaller, lighter, and much more durable electronics for satellites and deep space probes, places where failure is simply not an option. So, the big question is, how do you even build something so incredibly small and complex? You don't assemble it with a pair of tiny tweezers, that's for sure. No, you print it.
Yep, using amazing technologies like 3D printing, scientists can actually build these batteries layer by microscopic layer. It starts with a digital blueprint, which then guides a super precise process, like direct ink writing, to lay down the materials exactly where they need to go. What you get at the end is a perfectly formed, complex little powerhouse created from the ground up.
And that really brings us to the most exciting part of all of this. When you combine power that's smaller than a grain of salt with the ability to print it into almost any shape you can imagine, well, the possibilities are just endless. This technology isn't just about making our current stuff smaller, it's about making entirely new things possible. So the only real question left is, what will we dream up in power next?